Episode 1. How are black holes born? Every black hole in the universe started with a death. Not the death of a planet, not the death of a galaxy, but the death of a single star. For billions of years, that star fought against one unstoppable force, gravity. And one day it lost. That single moment created one of the most mysterious objects in the universe. So how does a dying star become a black hole? To answer that, we need to travel back to the beginning of a star's life. When we look at the night sky, stars seem peaceful, tiny points of light unchanged for thousands of years. Ancient civilizations used them to navigate oceans. They built myths around them. Some even believed stars were eternal. But scientists eventually discovered that every star is fighting a battle we can never see. Deep inside its core, hydrogen atoms are constantly smashing together. This process is called nuclear fusion. Every second, our sun fuses around 600 million tons of hydrogen into helium. That reaction releases an enormous amount of energy that pushes outward. At the same time, gravity is trying to crush the star inward. For millions, sometimes billions of years, these two forces remain perfectly balanced. As long as the battle continues, the star survives. But no star has an unlimited supply of fuel. Eventually, the hydrogen begins to run out. Fusion slows down, the outward pressure weakens. Gravity doesn't. Gravity never gets tired. For millions of years it has been waiting, and now it finally wins. The star begins collapsing under its own enormous weight. The collapse happens so quickly that the outer layers rebound in an explosion brighter than an entire galaxy. Astronomers call this a supernova. For a few moments, one dying star can outshine billions of others. It is one of the most powerful explosions the universe has ever created. But the explosion isn't the end of the story. After the explosion, everything depends on one thing: the mass of the star. If the remaining core is relatively small, it becomes a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. But if the core is massive enough, gravity continues crushing it. Smaller, denser, smaller still. There comes a point where nothing in the known universe can stop the collapse. Not pressure, not energy, nothing. Space itself begins to curve. Time slows down. Gravity becomes so strong that an invisible boundary forms around the collapsing star. This boundary is called the event horizon. Cross it, and nothing can escape. Not matter, not energy, not even light. A black hole has just been born. Long before anyone had seen a black hole, a few brilliant scientists predicted they could exist. In 1915, Albert Einstein published his theory of general relativity. His equations showed that gravity could bend space and time. Einstein himself doubted that nature could ever create something as extreme as a black hole. Just months later, German physicist Karl Schwarzschild solved Einstein's equations while serving on the front lines during World War I. His calculations revealed something astonishing. If enough mass collapsed into a small enough space, gravity would trap even light. For decades, many scientists believed it was only mathematics, until telescopes finally found evidence that black holes were real. Sometimes, science discovers the universe long before humanity can see it. Every black hole begins the same way. A star exhausts its fuel, gravity takes over, and one of the universe's brightest objects becomes its darkest. But that creates an even bigger mystery. If a black hole traps everything, even light, how do scientists know it's really there? That's the question we'll answer in the next episode. How about how? Every question has an answer.